I don't know if I do. I think I don't know. You might look right there. Okay, so our whole goal, you will find the least common multiple of 2 or more numbers. That's what our purpose is. Let's just simply write the prime factorization for 16 and 20. Okay, who can do that? Who can tell me how to get there? Mr. Kagan,
For multiple,
what do I do to find the prime
just
factorization?
count by 16s or 20s.
No, I have to do this. It says I have to use that method. How do I do it, Miss Kinsey? Trees, good. Factor trees. Kinsey, will you help me with the factor tree for 16?
4,
4 and 4. Are those two numbers prime?
No.
Oops, I know they're not, and for some reason my brain's open. Okay, they are not. So what do I do next then, Kinsey?
2 and 2.
2 and 2, prime. 2 and 2, prime. Okay? So the prime factorization for the number 16 is 2 times 2 times 2 times 2. Or we can say 2 to the 4th. Everybody agrees with that? I gotta get something up there and clean that camera off. There we go. All right, so let's do the prime factorization for 20. And if I'm doing it here and I'm taking the time to write it, you should also be writing it. Okay? It's your samples to give you something when you don't know what to do. Amelia, you want to help me with 20? 2 times 10. Do I circle either one of those?
2.
The 2 because it is prime. Okay, what about 10?
2 and 5.
2 and 5. Okay, so I have 1, 2. Do you agree?
No.
Well, I have more than one, but I have at least one. I have the first one.
Yeah.
I have a second one. Do I have a third 2
No.
in 20? Nope. Do I have a fourth 2 in 20? Nope. But I do have a 5. Do you agree with that?
No.
So 2 times 2 times 5 technically is that prime factorization. I remember the other day talking to you a little bit on greatest common factors about the difference between a row and a column. Okay? So do you agree that I have 2 rows in the 2 prime factorizations?
Yes.
Yes. Look at my columns now. We're going to circle. We're going to bring one number from every column down. From every column. Because we're dealing with multiples, not factors. I have a column of, this right here is a column of what? 2's. This right here is a column of,
2.
this one here is a column. What's in it?
2.
2. There's only one of them, but it's still a column, and it's a 2 column, right? All right. Next to that, I have another column of 2's. And I need to get my word or out of our way. What do I have here? What's this column? It's a column of 5's. It's not full, but it's a column of 5's. Now, if you multiply straight across this prime factorization, you will get your LCM for the numbers 16 and 20. What is 2 times 2?
4.
2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 5.
80.
What is 16 times 5? 80. The LCM for 16 and 20 is 80 using prime factorization method. Okay? You have to do the trees. You have to write it in prime factorization order. And do you see why the order matters? Least to greatest. Order matters. Okay? You have to write prime factorization order. And then you have to bring one from every column. kind of long and drawn out. Do you agree? Okay. Now I'm telling you, if it says prime factorization, you at least have to write it. Okay. But I'm going to show you a shortcut. Okay. Because I personally, the columns work and they will work every time. Every time. And if you grab onto the columns and that works for you, then always do the columns. You have to write prime factorization if it tells you to. But then I'm going to let you change it up here in just a second. I'm going to show you what I mean. Okay? Does everybody have this method written down on their paper? So you have your sample, so when you go to doing your stuff, your work, then you can say, I need help, and your resource first is that sample, right? And then if I still need help, where's your resource?
You.
Right here, okay? So then you come to me and I can work with you. But you're gonna have to check first. All right, well, let's go to, I'm gonna throw one in here. Yep, that's what I want. A while ago, we had 16 and we had 20. And I'm not doing my trees again, but 16 was equal to 2 times 2 times 2 times 2, right?
Yeah.
Okay, and 20 was equal to, give me that prime factorization, 2 times 2 times 2 times 5, am I right?
Yes.
All right. That's the prime factorization. We all agree. Okay, we're going to have a party. It's time for a party. You guys like parties?
Yeah.
Yeah. Okay, the only people that get to come to the party is like we're going to say the 2s are the rake straws and the 5s are the plumleys. Just pretend. Just play with this, okay? 2s are rake straws and 5s are plumleys. The biggest family of rake straws gets to come to the party. How many? So if all the 2s, I got 2s in 16, I have 2s in 20. Where's the largest family of rake straws? 16 or 20?
On the 16.
The 16. So all of these guys get to go to the party. All of them. Ha, too bad, so sad. You don't get to go. I'm sorry. All of these guys get to go to the party. Okay? And all of those guys equals 16. Do you agree?
Yeah.
Now, I don't have a 3s. I don't have any 4s. But I do have the Plumley family right here. And there's how many in the Plumley family?
5.
Just a 5. And only one of them. That's who gets to come to the party. What did we say 16 times 5 was?
80 people coming to play.
That's it. I met the qualification that it said using prime factorization. I wrote it. But then I just used the party. Okay? The prime factorization is this. The prime factorization is the product of prime numbers. Do you agree? So I wrote the product of prime numbers for 16. I wrote the product of the prime numbers for 20. Then I just hold the party. The largest number of people get to come. Let's go a little bit further. You're looking a little confused. Okay? Okay. Let's write the prime factorization for 14 and 18. I see some that are going, well, I can do that without a tree, because I know 14. Could you write the prime factorization of 14 without a tree?
Yeah.
Sure. Can you write it, Aubrey? Think about it. What are your prime factor? How do you get 14? 1 times 14 is 14, and 7 times 2. Are they both prime? All right. So I can write the prime factorization for 14 is 2 times, brain straw? My brain's working faster than my hand. 2 times 7, do you agree?
Yeah.
Is that the prime factorization?
Yes.
Sure. Can you do it for 18?
Yes.
If you need to do the tree, do the tree. If you know the prime factors of 18 without the tree, okay. Write write the prime factorization on your paper. Good. You get to check your shoulder partners. See your prime factorization. Yep. Check your shoulders. And then it can go all the way down. Is that prime number right there? So you gotta change that. So you probably have. Okay. Check your neighbors for the prime factorization. Okay, you got that? Okay, write the prime factorization of this number. We did 14, right? This is your final answer, right? But write the prime factorization for 18. You're on track. You really are. You really are. Have you got the prime factorization for both of them written? Good. Find the LCM then. We'll get there. Prime factorization written for both numbers. I see 14. Where's the prime factorization for 18? Write it underneath it, okay? That's not prime factorization. Isn't it? Okay. Good. If you're writing prime factorizations, you can only have prime numbers there. So if you're using the number 9, it's not a prime factor. It can't be written in that prime factorization. As I walked by, though, this is what I saw. It was 2 times 3 times 3. Do you agree?
Yes.
Okay. Where's the biggest group of 2s? Just pick one of them for me. Where's the biggest group of 2s?
18.
Okay, I'm going to bring these. So I've got 2. Does this 2 get to come? No. The other one's already there. Can't come.
Are they?
What about the biggest group of 3s? And how many are there?
18.
Biggest group of 3s, and how many are in that group? 2. Bryson, where's the biggest group of 3s? How many 3s are in 18?
Oh, no.
There you go. These 2 get to come to the party. Now, this one we already looked at, right? There's only one number we haven't checked to see if we want to bring them, if they get to come. Does the 7 get to go to the party?
Yeah.
Sure does. Okay. So this one got to go. Well, if I brought everything from 18, then I could just say 18 times 7, can't I? And would that give me my LCM? Yes. Do you see why, if you're struggling to multiply, you may have a problem?
Yeah.
Because if we've got that all there and we can't multiply 18 and 7 correctly, are we going to get the right LCM? No. Well, 8 times 7 is what?
126.
Okay, Amelia, I love how fast you are. That is awesome. But you got to give everybody else a chance too, okay? And 8 times 7 is not 126. Because 8 times 7 is 56, okay? So I got a 6, and I'm going to carry the 5. 7 times 1 is 7 plus 5 more, 12. 7 and 5 is 12, I agree. So my LCM is now 126. And Amelia had it, she knew it. But she's just got to give the rest of us time, right? Okay. All right, let's do number 5 there. Again, you have to write the prime factorization. You have to write the prime factorization. And I would say I probably should start seeing some trees. Because I don't know if we've still got these numbers that we can just do without them. Okay, I can't tell what you have written there. And is that prime factorization, are they in the right order? Prime factorizations have to be written from least to greatest. Okay, so you need to fix that. Remember, a prime factorization must be written from least to greatest. Okay? And you're fine. Good job. Yeah, exactly. You do table check. Okay. Do you agree? So change that. Okay. And you're gonna want to so erase that and fix it. Okay? Okay. All right, let's talk. As I walk around, I saw the prime factorizations, and some of you, you're gonna have to decide, am I gonna use the tree? Because I saw kiddos say that, the prime factorization of 28 was, 2 times 2 times 7. I saw that one, and most kids got that one. But then when they went to 36, I saw, what did I see? 2 times 2, no, I saw this one. This is the first one I saw. I saw this. Times,
Times 4.
I think I saw that. I did see that. I also saw somebody go, I saw this one. 3 times 3 times 3. Okay, now, how do you check? Everybody listen for a minute. Even if that's what I think, how do I check it to know whether it's right or wrong? How would I check it, Melissa? Well, I could, but that's what kind of a statement there, David? What does the dot tell you? Multiply. So 3 times 3 is 9 times 3 is
27.
So I know there's something wrong with that one. But I also know that 9 times what is 36? Because I had this. That's true. 9 times what is 36? 9 times 4. What are the prime factors of 4? And 2 and 2. So at that point I could say 2 times 2 times 3 times 3. Okay? And I am seeing some kids use these and use those columns. So I'm going to start showing the columns as well so they can double check their work. Do I have any 3's in the prime factors of 28?
No.
Nope. Do I have a 7, right? That was my last one. Okay. Do I have a 7 in the prime factors of 36? No. So I just simply draw a line. It's a placeholder. I don't have any, but I know I had to look at it. Now, if I looked at this and I said, okay, here's my column. I have a column here. 2. I have a column 2, a column 3, a column 3, a column 7. And I know now I need to multiply all of them. 2 times 2 is
4
times 3 is
12
times 3 is
36
times 7 is 252. Okay? If I chose the party, I'd still get the same thing. Okay? The thing about using the rows and columns is on LCM, it's one from every column, but they have to be lined up. And GCF, it's every full column. So if I looked at 28 and 36, can somebody tell me what the GCF of those two numbers is? What's the GCF of 28 and 36?
7.
No, 2, yeah.
What did you say? Somebody said it right here. Faith. 4. How do you know that, Faith?
Because 4 times 7 is 28 and 4 times 9 is 36.
Well, that's true, but how do you know it using that rows and column, Connor?
Because you have 2 pairs of 2s.
I have a full column right there of 2s, and I have another full column of 2s, so I bring one of each. I don't bring anybody else because they're not full. For GCF, the F stands for full columns, and it's 2 times 2 equals 4. So see, I can use the same tree, the same prime factorization, and I can do both. Okay? Either way is acceptable. Your assignment. It's small because I want you to practice with it. But let's get it out. Go to your math journal, get it out. Because I know what happened the other day when I expected you to read your directions on your own. I remember. And I remember kids just chose the way they wanted to and did it however they wanted. And they lost points. So they didn't do the process right. So everybody's got it out. Page 26. Everybody's there? Everybody look at it. Numbers 1 through 6, the directions say. And you need to underline a very important part of it. Find the LCM of the numbers using, underline that part that says list.